Hi guys, I guess it's time to do the dismantling video. Let me just first remove the some of the 3D printer parts. So this guy over here, okay, you can just unscrew it, okay, and then you can remove it. So I guess this is because it can be removed, I can more or less use some vacuum cleaner and just clean the dust if necessary. Okay, so the other side, maybe I remove the magazine first. Okay, so the other side. Okay, so we can remove it. Okay, let's remove this over here. Is this the one? Okay, this is not the one. Okay, so I believe this video is going to be a long video, so yeah, so some might want to watch it in double speed. Okay, so this is not the one. Let me get the correct one. Alright, so basically I'll also update the part list in the my GitHub account, so you can go ahead and check it out. Yeah, so it should be in one of the documents inside. Okay. Okay, next let's remove the muzzle. So this actually locks the battery tray. So gonna remove this. I'm just gonna put it here first. So the battery is basically here. So this is a this is quite a powerful battery. It's 1.5 mAh. So yeah, it will last pretty long. Okay, so I use the worker hand grip. I realized that this grip you actually do not need to have any extra sort of rail attached because there are two grooves over here, these two grooves that matches with this two portion nicely, so you can actually attach it. Yeah, so that's pretty convenient, so that's why I use this, as well as it is quite comfortable to hold on to. Yeah, so for this build I think it's just nice. Okay, so for the front part, there's one more, this rail. So basically in the demo video I actually did not have this rail installed. I use a one I bought, but I realized it's not so nice, so I went ahead and 3D model myself one. Basically I just modify what I had previously and then just fit it, so it should be quite okay. Yeah, so I'm gonna remove this. So for the front part, that's more or less it. So let's move on to the stop. Okay, so for the stop, I can just remove this. This is the cheek rest, right? So you open up and you can have access to the Arduino board. So this is the housing that I made for the Arduino board. So if you were to, so that it's very easy for you to remove the board. So if I have another program, so I'll just take out this board and then just swap it out and then just insert it, and you will run the other program that I wrote. Yeah, so this is a quick access to the board itself. The inner portion basically is just fit with this type. Okay, it's I think it's 20 connection. So when you slot in the 3D model that I made, you'll be just nice. And there's probably no way whereby you can insert the board wrongly, because it won't fit if you try to insert it in any other position. So this is this way I do it. Okay. So let's try to remove the Arduino. So these are all the connection. So don't be intimidated by all this connection over here. It looks pretty messy, but in fact it's actually quite straightforward. Most of them is just a 2-wire setup. So I'm going to try to remove. Okay. Okay, some I've taped it just to secure it. So okay, I'm at a strange angle, so I cannot really see that well. So it takes a while. So yeah, feel free to watch it in double speed or to speed things up. Okay, so I'm gonna remove. Okay. Okay. Let me see what else is there. Yeah. So as you can see now, it's all removed. So basically, these are all the connections. Yeah. So most of them, for example, you see this guy over here. It's color on the one side, the other side they are actually all ground. So it's basically just the signal wire and the ground. Okay, so most of the connection is this way. So if I would say that if you know how to rewire a drive, this connection is should be quite straightforward. Yeah, the circuit is actually not that complex. Yeah. So this I'll put aside. So this is like one module. So I'm going to, I think I can continue to remove some of the stuff, make things easier for me. This guy is actually the voltage sensor. Yeah. Yeah. So I didn't glue the stock yet, but once I reassemble it, I'll probably glue it together so it's more stable. So again, there's one connection here. So basically this guy is just to the power switch below. Okay, so now I have this separated as one piece. So this rotary encoder. Okay, I think it's easier. Okay, I'm just gonna remove all the connections so it'll be easier for me as well. I probably should have just desolder the pin and then resolder it, but anyway. Okay, so this is just some connection wires. So now you have this whole bulk of it. Okay, so now I'm just gonna release it. Okay, so I'll just pull it out, and then this will be removed. So you can see for the stock itself, I'm just using a waffle dart as a spring. Let me just put it down. So yeah, okay, there's a spring, so it should work quite well. So inside here is actually a rotary encoder. I just simply remove this and then remove this nut over here, and it can be removed. Yeah, like I say, I probably should have desoldered these pins and then solder the wire, and then it's easier for me to assemble. But anyway, okay, so this is a push button and then a rotary encoder. I find it's quite useful. Alright, so now what we're left with is actually the oh, I forgot, I need to remove this guy over here. So I need to find a screwdriver, a flat head to do that. Okay, so there is a slot underneath, so just pry it open slowly. Okay. Yeah. Yeah, So this is if you assemble it the first time, is friction fit, it should be quite lasting, but of course you can apply a little bit of I guess white glue or something like that just to position it nicely. So previously I printed this way, but I realized sometimes the printer might have problem printing this curves area. So this time around I actually printed it this way up, okay, and then I've support around the places that require support, and it's actually printed out quite well as well. I set the layer height to be 1.2, I believe, so it's a lot finer, and it works well. So it's not meant to be taken apart frequent, so the more you take it apart, the connection will be weakened. So anyway, okay, so this is the heel. Yeah, so now these are all the parts that we took out so far, right? So yeah, so I'm going to remove all the screws, and then we'll come back. Okay, we are back. There is really a lot of screw. I have still a few that I did not manage to get it out of the shell. So basically, let's open this up. So when you split it up, okay, so there are few basically just masking tape, sort of like for me to hold down the wire, so that when I close the shell, I will not sort of like accidentally clamp onto the wires. So these are basic guides. Okay, so if we were to remove this, then it actually comes pretty clean. It should be two halves, okay, like this. Okay, so this half basically I only need to worry about the selector switch. Okay, so this and then the trigger section basically I can remove. It is not secure. Okay, so it's actually below here. So for the top halves, basically it just concerns the selector switch itself. So later on we'll take a look, but let's just remove this back piece. It's just no friction fit, so just remove. Again, this is a 3D printer part. This is a Oled display, so it is again held in place because of the angle itself. So I just remove. Okay, I have a screw here which I need to keep. There's another one here. Let me just remove the screw first. Alright, so let's just talk about this portion first. So again, the trigger section, you can just remove it. So these are very small micro switch that I place with the 3D printed part. Now one thing to take note of is because there's a pole over here. So for the corresponding closing shell, the other half, I have to like more or less remove a little bit, half of it, like this guy over here, half of the pole, so that I can insert the screw as well. Basically to make some space, I also sort of like remove just a tiny little bit here. Alright, sorry. Okay, so again, this is the trigger section. So as you can see, each of the switch is nothing but a pair of wires. One is to the ground, one is to the Arduino pin. So again, this is again one to the ground, one to the Arduino pin itself. So now I can actually keep this trigger section. Okay, so let's continue to remove. So I'll just remove this guy over here. Okay. Okay, what else? Okay, I'll remove this thing over here. Okay, remove this cosmetic piece. Yep, so this thing over here, this cosmetic piece over here. Okay, it's a bit tight. Okay, this switch is basically just there so that it will have some friction for the jam door. So it's actually just to place there just for the friction itself. This piece over here. Okay, so we come back to here. Again, this piece is 3D printed and is friction fit. Okay, now we can remove this section over here. Okay, let me get a container. Do not want to lose this stuff. Okay, this will be good. Okay, now let me get a few more containers. Okay, remove this guy. There's a spring here, so better be careful. Okay, this piece over here. Now what else? Okay, let me just remove this OLED display. So you can just pull it out. So the OLED display basically have like 4 wires. So it's very simple. You just have the 4 wires ready, and then this end you just plug into the Arduino, right? Okay, so again I can keep this now. Okay, I'm just gonna keep it here. Alright, so what else? So okay, let's remove the okay, this piece over here, 3D printed friction fit. Okay, the rest will require some I'll remove the screws offline. So and we shall continue. Okay, I think we are back. So let's just remove one thing at a time. So now it's the flywheel cage itself. Okay, I find this the most tedious to sort of put into position because it's pretty stiff. Okay, so it is a Mosfet, so I do it such that you can remove the connection. Okay, yeah, so once removed, this is what you have. Okay, so I'm trying out a shorter inner barrel to see whether it affects the accuracy. So far it proves to be fine. I find that the AccuFake, the accuracy is not as consistent. FVJs is still the best, followed by main gun, I believe, the darts. Yeah, so I'm just trying out different combination of inner barrels, so different length, whether it affects or not. I have a full length one, so maybe I'll try that in the future, but more or less it is something like that. Okay, so for this guy over here, this plate over here is basically is a something I bought. Is basically 3 capacitor kind of PCB, whereby you just solder it to reduce electrical noise. Now if you don't have this, it's not the end of the world. You can still solder your basically the capacitor that we bought. I'll show you. Basically the pusher uses that, so instead of using the pre-made one, you can do that. So over here I have a diode as well, flyback diode. Okay, because I'm using a Mosfet, rather than putting at the Mosfet, I put it as close to the source of the interference as possible now. So you can do it here. Also is more space efficient, I would say. Yeah. Okay, so this is the flywheel portion. Okay, so now the pusher itself. So if you remove it, so basically it's going to be controlled by the brush ESC. So there are a few reasons why I choose to use this, which I'll talk about later. Okay, so if I were to remove it, it's basically one unit by itself. Now, so this is the one that I talk about, the capacitor. So if you don't have the so-called pre-made capacitor plate, you basically can use this capacitor over here and then solder it. I'll put a link to the sort of the write-up about why you want to put it there. Okay, so this is the pusher. So as you can see, so this is the one that you can snap on and then you can extend it. Okay, yeah, so this is one unit by itself. Yep, so I'm gonna put it here. Alright, so let me see. So next, this is the Hall effect sensor. So basically what happened is for the magazine itself, I have magnets. Okay, so I have two sensors over here. So they'll detect, according to the magnet that you place. So if you have two sensors, of course you can have like 4 different type of combination. Without the magnet, one, this side, and then both, right? So if you will remove it, so it's nothing but 4 wires. Okay, so this is the Hall effect sensor, right? Okay, so yeah, so this is just by itself, another unit by itself. Okay, so for placement of the magnet, okay, I also 3D model like a guide. So you have a magazine, you just put it down, so you can just put a magnet accordingly corner to corner, and you will not miss the spot. Okay, so it should be quite safe. So for example, this guy, unit 1, so you just place it down and you just place the magnet here. So I'll place the dimension of the magnet on screen later on. Okay, so let's continue to remove. So again, so this is the Mosfet. Okay, so I just prepare in one unit. So so the next video I'll probably go through the circuit diagram, how I wire all this up, like how do I wire this Mosfet to have a control that attach to the Arduino, how to control it, and then how do I wire up the Hall effect. So yeah, you realize I don't use any extra resistor. Basically I use the internal pull up from the Arduino board itself. Yep. Okay, so this unit itself, so this is where the battery goes, right? So you can supply to power to the Mosfet, and then the Mosfet to the flywheels. You have another set of power to the pusher, and then another small lead out to the voltage sensor. So in fact, if I were to remove, this is just one kind of spine, okay, whereby you can just prepare separately. Okay, so it's more convenient. Right, next, of course, this is the one that detects the magazine. Again, it is just a signal and a ground, so you can see. So next, so this is the one. So for this is just a brush ESC. It's very simple. Receive power from the battery itself, supply power to the pusher. Well, I choose to use the ESC over the 3 Mosfet setup. Basically I can use a 3 Mosfet setup to do motor braking, and in fact it's actually the reaction time is much faster compared to I use this, because I'm in the mercy of how this thing is being how this thing works. So I have to program around it. But well, I choose this mainly for convenience sake. I don't want to sort of like solder the 3 Mosfet all together, and also this also provide power to the Arduino, so I don't need another buck converter and wire it up. And sorry, the power is actually supplied from here. So this is actually an on-off switch. So altogether I can use this with an on-off switch, and then supply power to the Arduino, and then a signal to control the pusher, and then it itself, it comes with capacitor, and also is the signal should be quite clean. So yeah, so it's more of a convenient over anything. And yeah, so it costs less than $20 USD, I believe. I mean not USD, I mean SGD for myself. So yeah, so that's why I choose this. In the future I might try the 3 Mosfet setup, yeah, just but for now I think it is convenient, so I use it. Alright, so now it is just this switch over here, which is the safety switch, right? So I'm not too sure whether I can pop it out. Okay, yeah, I can. Okay, it's a bit tight. Maybe should I? Maybe I'll do it offline to pop it out. So basically that will conclude this side of the shell itself. Okay, going into this modification, my objective is to do as little shelf modification if I can. So basically you can see that I only cut off this portion and then cut off this portion for the Hall effect sensor, and then do a little bit of cleanup here and remove something here to not obstruct the wiring. So if there's any places that obstruct the wiring, I'll just take care of it, which is very minor kind of modification to the shelf. So yeah, so if you want to fit the ESC better, you can just trim this down, which I did not do. I try to get away with as little modification as possible. So this side of the shelf itself. So we'll come back for the other side. Alright, so for this half of the shelf, there's actually not much to talk about except for the selector switch. So it is secured using 4 screws over here. So I did a 3D model for the switch itself. I was only able to get this switch from the China website, so I'm not too sure how available it is overseas. Anyway, yeah, so I also make a 3D guide to sort of you can place it and then you can mark the position of the placement of the screw. So if you want, you can just remove it and you should be able to secure it nicely. So let me get a sample of the switch. Okay, so this is how the switch looks like. Okay, this is how the switch looks like. Yeah, so you probably can find something then, maybe a replacement for this portion. As long as it's a 3-way selector, I think it should be fine. Yeah. Yep. So again, it's 2 signal wire and then just 1 ground to the Arduino itself. So there you have it. So that's the dismantling of the blaster itself. So I hope you enjoy the video. If you have watched until now, thank you very much for watching this long video, long and slow, I guess. Anyway, I guess it's time for me to put everything back. Yeah, so again, if you have not subscribed to my channel, please do so. If you find my content interesting, yeah, so and thank you very much for watching. I'm Tungsten. By the way, so the next video I'll try to go through the circuit. Yeah, so again, thank you for watching. I'm Tungsten.